Copy, there are three things. Okay, in copy, how many things you have it? Three things. But majority people will tell only two copies. Okay, one who is dealing with the C language, right? He will tell three copies. According to me, there are something called as a reference copy. Other one is called as shallow copy. Wait a second. Shallow copy. Other one is called as deep copy. Okay, deep copy. A one, a two, a three. Reference copy is very easy. Okay, for example, A is equals to 10 and B is equals to A. This is called as a reference copy. Both IDs are same thing now. If I check it out, ID of A, and if I tell as ID of B, right, it is nothing but same thing. This is called as a reference copy. This is called as what? Reference copy. First one, reference copy. I'll give you the example now. For example, okay, A is equals to 10, I will tell it. A is equals to 10, I will tell it. And B is equals to A, I am telling it. All right. If I tell as ID of A, and if I tell as ID of B, address are same, guys. Address are same. And this is called as I'm copying the reference here. Right? A reference of the data, right? That is called as what? Reference copy. The diagram will be like this. Okay. Both there is a 10 value. Both A and B are pointing to the same memory. Is called as what? Reference copy. This is what the what is that? Reference copy, right? Now coming to your deep copy, sorry, shallow copy. What is a shallow copy? Okay, I'll tell you what is the shallow copy. You will not get the difference right now. I will tell you some movements. At that time, you will get to know. You will get the analyzation. Got it? I want everyone's, like open your mind and watch this. What I'm doing. A equals to. I'll tell us. I'll take a list now. 10, 20, 30, 40. I'll tell it. Right? 40. I'll tell it. I'll tell us like this. I'll tell us B is equals to A dot. I'll just tell us copy. This line is called as what? This line is called as A dot copy. I'll tell it. I'll tell us A dot copy. Okay. This line is called as shallow copy, but there is nothing to prove it in here. Okay. If I tell us A, same data, B also same data. Whether it is pointing to the same memory, absolutely not. Okay. ID of A, I will tell it. It's a different one. ID of B, I will tell it. It's a different one. Right? Got it? Okay, shallow copy, what happens? You have a data, over here. Okay, you have a data here, Okay, now what are you doing it? Now you're just copying, this one, A dot copy, and you're copying to B. A dot copy, you're copying to B, right? So now what happens now? If I tell us A of A dot, I'll just tell us like append. Okay, append, I will tell it. A dot append, I will tell it. A dot append, I'll tell it as 60, I will tell it. A dot append, I will tell it as 60. I'll tell us like this. If I tell us A, append is adding to 60 is adding to this. ID means like reference ID, ra? Like you have an identity card, you have a unique ID. That is what the ID is. For A, you have a different ID. Like an address. Here you cannot get the address. Okay. For that, they will encode it. That address is encoded, and they are generating the unique ID for each element. That is what the ID is. Got it? So if I tell it as B, guys, whether B is getting affected? No, B is not getting affected. Then how, sir, it is shallow copy? What is, sir, shallow copy? ID also different. It is copying just an element and it is storing in one different memory. Okay, cool. Right. This is a group data, guys. I don't have a data inside a data. A list inside a list, you don't have it. Now, what is the list I'll be taking is a list inside a list. Okay, for example, A of A equals to, I'll just tell as 10, 20, 30, I'll tell it, comma, I'll tell it as 40, 50, 60, I will tell it. Okay. Now what I'll do is I will draw the block diagram for this. I will tell it as A is like this, right? I'll draw the block diagram for this. I'll come here. Okay, so everything, whatever I'm doing it is a shallow copy. Okay, shallow copy. So what I'm doing it, I have A equals to what I have it, 10, 20, 30, I have it. Inside this one, I have it 40, 50, and 60, I have it. Right? I want you to draw this block diagram for this. The block diagram for this will be something like this. It will be object, but I'll be drawing like this for your understanding. 10, 20, 30 I will draw it. 30 I will draw it. This is the one dimension. Okay, 0, 1, 2, and 3. And here you have a minus indexing also. -1, -2, -3, and -4. Okay. Sir, what will be here, sir? What will be here? If this one's address is 1000, and that is what is pointing to A. A is pointing to this one. That is unique ID is 1000, right? Unique ID is 1000. Object unique ID is 1000, something like that. Now here it is also pointing to one more object. Let me take it as here 2000 instead of why? Because it is entirely one data, one object. It is there, different object, right? It is pointing to somewhere which is nothing but 2000, guys. Right over here 2000. Okay, so here now what it is stored is like 40, it is stored 50, it is stored 60. Okay, here also you have indexing. You have 0, 1, 2, and you have -1, -2, -3. Like that itself you have it. And this one's address is what it is 2000. This one's address is what it is 2000. That is what I am storing it here. Is that cool? You got the block diagram for this one? You got the block diagram, guys? You got the block diagram? Right. For example, if I tell it as A of 0, A of 1, what I'll get the output? I'll get the output called as 20. Right? If I tell it as A of 3, A of 2, how it will be going at? Okay, A of 3 will go, oh, 2000, it will go for here. Here, from here, it need to go for the second index. In the second index, what I have it? 60. I'll be getting 60 like this. So much you got it? How I'm getting 60, how I'm accessing this? For A of 3, it will go for A of 3. It will say, oh, 2000, I want to go for 2000. From here, which index? It will go for the second index. It is going for the second index and I'm getting it 60. Done, 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 done. So much is clear, so much is clear, so much is clear. Same thing with the execution also, I'll show it. Okay. If I tell it as like A of 2, if I tell it as A of 2, what I'll get it? I'll get it 30. If I tell it as A of 3 of 2, right? A of 3 of 2, I'll get it what? 60. Is that right, guys? Now look onto this. Look on 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 this. I will tell it has A equals, sorry, B equals to A dot copy. A dot copy, I'll tell it. Okay, A dot copy, I'll tell it. It is exactly copying whatever the element you have it here. Exactly copying it. Nothing to worry about this. Now I will draw the block diagram for this also. Right? Inside the B, what you have it? Inside the B, what you have it? Same thing, exactly like A itself. Okay, exactly like A itself. So what I'll do is I'll come here, I'll copy this. Right? This is nothing but B. It is a copied one. So I'll just tell as 10, I'll tell as 20, I'll tell as 30 here. I'll leave a gap here. I'll tell you for a reason I'm leaving a gap here. I don't know what it is here. Okay. So much it is. Okay. So much it is. Now, if I tell it as like even this one also having -1, -2, -3 address, that this blah blah blah. Let me tell you this one has 3000. A का address different है, B का address different है. I am just assuming it. 1000 and 3000. I'm assuming it. Okay. और चाहे आप ID देखो तो क्या होगा? ID of A is different. ID of A is different. ID of B is different. इतना ही मुझे पहचान में आना है. यही मुझे चाहिए मुझे. Okay, ID of A is different and ID of B is also different, right? So same thing I have written it here also. ID of A is different, ID of B is also different. No problem with that, right? Now I'll tell as A now, I'll tell as B now. Both the data are same, guys. Both the data are same. Now what I do is A dot append, I will tell it. A dot append, I will tell it. I will tell it as append called as, I'll tell as like 100, I will tell it. Append 100, I will tell it. Okay, I'll tell it as A. ए के लिए इफेक्ट हो रहा है, राइट? वेदर बी के लिए इफेक्ट हो रहा है, बी के लिए बिल्कुल इफेक्ट नहीं हो रहा है, राइट? सो ए व्हाट हैपेंस नाउ, दिस ए व्हाट हैपेंस नाउ, इट विल ग्रेजुअली इंक्रीज बाय one more block. It will gradually increase by one more block, and this is nothing but fourth index. Here what I'm storing it, 100 I'm storing it, right? Whether it is affecting to here, it is not at all affecting to here, right? Same thing, I'll make changes for B also, guys. I'll make some changes for B also, guys. B dot append, गौर दीजिए इस पे. B dot append, I'll tell us 200 here, right? I'll enter this. Whether it is affecting to A, no. Whether it is affecting to B, yes, it is affecting to B now, right? It is affecting to the B. Sir, how, sir, it is shallow copy? Again, I'm doubt, sir, right? So I'll tell us this one has nothing but 200. I'll tell us what 200 now, right? So this is nothing but fourth index, third index. This is nothing but what fourth index, right? Here fourth index is different, fourth index is different. I've left this gap for a reason. I have left this gap, guys. For a reason, I have left this gap. Okay, for a reason, I have left this gap. Now look onto this, guys. Now look onto this. Can I access this memory, guys? Can I append one data to here, guys? Shall I append a data to here, guys? Shall I append one data to here, guys? Shall I? Tell me how to append the data to here. How to append the data to here? I just need to tell a of 3 dot append. I will need to tell it. That's it. If I want to tell it, I will append the data to here. Is that cool? Is that cool, guys? Okay, so instead of telling just a a, I'll just tell us a of 3. a of 3 को जाओ और इधर मुझे डेटा append करना होगा. इधर मुझे डेटा ऐड करना है. तो मैं क्या करूंगा? a of 3 को जाऊंगा और append करूंगा मैं. Right? That is what I'll be doing it now. Right now, you look onto it. Careful look onto it. A dot append. Sorry, not a dot append. A of 3 dot append. A of 3 dot append. Append, I will tell it. Append, what I need to do it? I'll tell it as like 400. I will tell it. 400. I will tell it. I'll enter this. एक लिए यहाँ पे आए क्या है ये यहाँ पे क्या है ये 400 आ गया right same data guys I will enter it here 400 right 400 I will enter it here this is nothing but what third index and look onto this magic wait for the magic A के लिए ऐसा आ गया B के लिए you look onto this guys you look onto this everyone on the screen if I tell it as B look onto here guys it is also affecting to B also. And this concept is called as what? Shallow copy. It is affecting to B also. Normally you are appending it, it is not affecting it. Here you are appending it, it is affecting it. That means I'll conclude this topic. That means, okay, when you are copying it, you are copying only upper element. You are only copying upper element. When you're copying it, you're copying upper element. Okay, it's like this is also sharing the same memory. And this is also sharing the same memory. Okay, when it is coming to the inner dimension, it is not copying from the depth. It is not copying deep. It is only copying what shallow it is copying it. And this is called as what shallow copy. Got it? Inside the element, it is just pointing to the same address. Got it? If you make changes to here, it will affect to A also, it will affect to B also. It's just like you have 2 bedroom and 1 attached bathroom for a same room. It's like that. You can remember in that way. Right, guys? Okay. In that way, you can connect it. Got it, shallow copy? Got it, shallow copy? Take down this. Discuss the deep copy. What happens in the deep copy? Okay. So I'll just give you the direct straight away the program for you. What is in the deep copy? Okay, that is okay. Syntax error, you have it. Okay, deep copy. What is the deep copy? Okay, you have a value. This is what the a value is. This is what the a value is. Now, just you remember this. That's more than enough. Okay, import thing I will do it. Okay, right now I cannot do it. Import means it's just like a hash include. You will use it in C language. You will use hash include, and in Java also. If you are gone with the Java, you have an import statement itself. Same like it will be doing it. There is one package called as copy. Okay, there is one package called as copy. Right, I will import that file to my current folder. Okay, I'll import it. Now what I do is, I will copy this B, I will copy this A, whatever the content you have it in A, I will copy that A to B. Okay, how do I copy it? Okay, there is something called as method called as deep copy method. Okay, there is method called as deep copy method. Inside the copy, you have something called as deep copy. Okay, deep copy method. I'll tell it as deep copy of what? Deep copy of A, I will tell it. Okay, deep copy of A, I will tell it. I will copy that whatever the content you have it in A, I'll copy to B. I'll tell this. Now B is also same thing, guys. B is also same thing. Yes or no, yes or no, yes or no. Now what I do it? Okay, so I'll just tell it as like A dot append. A dot append, right? A dot append. I'll tell us -10, I will tell it. A dot append -10, I will tell it. So whether it is affecting to B, guys, whether it is affecting to B, not at all. This was no problem in the shallow copy only, right? How it will be affecting to the deep copy. The problem was with here, right? Now what I'll do is A of 3 dot append, I will tell it. Append, I will tell it. I'll tell it as -400, I will tell it. -400, I will tell it. I'll tell it as A here. It is adding to the A, guys. Now I'll just check it out whether it is affecting to the B or not. In shallow copy, it was affecting it. Whether it will affect in the deep copy, guys, it will not affect in the deep copy. All right, it will not affect in the deep copy. This is called as deep copy. It is copying from the depth. It is copying from the depth. Okay, so I'll give just one diagram for you how the deep copy will be. You can take it down. Okay, so deep copy will be something like this. Okay, for example, deep copy, I'll tell it. Okay, I'll tell it as deep copy. For A, it will be something like this, guys. A will be something like this. You have it like this. 10 you have it, 20 you have it, 30 you have it. Here you have 2000. Here it is nothing but 1000. You can tell it. That is nothing but A you are giving it. So in 2000 you have it something like this. 40 you have it, 50 you have it, 60 you have it. For now you write it down minus 400. You're adding this minus 400, and this is nothing but 2000. In deep copy, what happens is it will copy the entire element. It will copy the entire element, right? 10, 20, 30, and it will copy this one. It will copy this one, but it will not copy 2000. It will create its own value, right? In 3000, it is storing same exact element 40, 50, 60, and minus 4000. Right, minus 400, right, minus 400. So even this one both having index, let's say like 0 1 2 3. This one also 0 1 2 3. This one also having 0 1 2 3, and this one also having 0 1 2 3. So this is nothing but 3000. Separate, you know, you get it like all the restrooms, right? So here it is nothing but like, I'll just tell us like 4000 something. There is nothing but B. Now look on here. If I change it, if I tell it as like append, I will write it as like this: append for what, guys? A of 3. I'll tell it append A of 3. I'll tell it as what? For 40, I'll tell it like you know, minus 90. I will tell it minus 90. I will tell it where it will get appended. It will affect only to here. 90 it will be added. That is nothing but 4, right? It will never be affected to here. It will never be affected to here, guys. That is what I want to show you in the deep copy. That is what it is. That is how it is. But in shallow copy, it will affect to here also. Why it is affecting to here? Because here the address will be 2000 itself. Both are pointing to the same memory. But in shallow copy, it is a different memory. It is copying in the depth. All the values, it is copying in the depth. It is creating for each the values. Done.